Hello students, welcome to section 16. We'll be starting with some problems related to nature of the roots of a quadratic equation. So here I have example number 1 from page number 46. The question is that 2x square, we have a quadratic equation 2x square plus 6x minus 5 is equals to 0, and we need to find the value of alpha plus beta and alpha times beta. Now, as we learned in the previous section, that alpha plus beta is equals to minus b by a, and alpha times beta is equals to c by a. Now, here we have our equation. We have 2x square plus 6x minus 5 is equals to 0. All we have to do here is compare our equation to the standard equation of a standard quadratic equation. So I have ax square plus bx plus c is equals to 0. So this means that I have a is equals to 2, b is equals to 6, and c is equals to minus 5. Now I have alpha plus beta is equals to minus b by a, which is equals to minus 6 divided by 2. This is equals to minus 3. And I have alpha times beta is equals to c divided by a, which is equals to minus 5 divided by 2. So these are my solutions for alpha plus beta and alpha into beta. Now moving on to equation number 2. Example number 2 from page number 47. Sample 2, page 47. Here we have the question with a quadratic equation x square minus 13x plus k is equals to 0. And there is one additional information given to us. It is stated that the difference between the roots of the equation is 7. So as we know that any quadratic equation has two roots, one of them is alpha, the other one is beta. Now the question is stating that the difference between the two roots. Difference means that there is a minus sign. So I have alpha minus beta is equals to 7. Now, before we start off, we have to compare our equation to the standard quadratic equation. So I have x square minus 13x plus k is equals to 0, and my standard quadratic equation is ax square plus bx plus c is equals to 0. This implies that a is equals to 1, b is equals to minus 13, and c is equals to k. Now, we all know that give me a moment, I'll be removing this. Now we all know that alpha plus beta is equals to minus b by a, and alpha times beta is equals to c divided by a. Now in our case we have b as minus 13, a as 1. So alpha plus beta is equals to minus. Now the value of b is minus 13 and the value of a is 1. And for alpha times beta we have c is equals to k and a is equals to 1. This means that alpha plus beta is equals to 13 and alpha times beta is equals to k. Now, once we get this, we have an additional information that states that alpha minus beta is equals to 7. So now I can say that this is equation number 1, this is equation number 2, and all I have to do is solve these two as linear equation in two variables. As I do not know alpha, I do not know beta, all I have to do is solve this as a pair of linear equations. So I'll be adding equation 1 and 2, equation 1 plus 2 That gives me alpha plus beta is equals to 13. Alpha minus beta is equals to 7. Once I add this, the sign does not change inside the bracket. I have 2 alpha plus 0 is equals to 20. This implies alpha is equals to 10, which eventually gives me beta as 6, or beta as 3, not 6, beta is 3. Now, k from our equation of alpha into beta, we are going to call this as equation number 3. We know that k is equals to alpha times beta. So in equation 3, all I have to do is substitute the values of alpha and beta. Alpha times beta is equals to k, which implies k is equals to 10 times 3, which is equals to 30. So my solution is that k is equals to 30. Now, before we move on, we're going to go back and look at how to solve this question. So initially we were given this equation over here. We were given this equation. We have the value of A, we have the value of B, and we have the value of C. But C value is written as K, and we have to find the value of K. Now we all know that alpha plus beta is equals to minus B by A. This is very important. And alpha into beta is equals to C by A. Because as we find alpha plus beta, we get the value, and we have an equation here that the question has stated that alpha minus beta is equals to 7. So all we have to do is use our previous knowledge from our chapter number 1, which is linear equation in two variables, solve by adding equations, adding equation 1 and 2, we get the values of alpha and beta, and then we move on to putting the values of alpha beta into equation number 3, and we get the following value for k. Now, example number 3 is a very good question, and I'll recommend you that all of you start remembering formulas, or at least revising formulas for a plus b whole cube, a minus b whole cube, a plus b whole square, and a minus b whole square. All these formulas are going to be used in order to find alpha beta values for roots of a quadratic equation, and it will be helpful for you, and it will be much easier for you to solve questions once you revise these formulas. Now, these example number 3 will not be done in this video section, as this is an intelligent question and we'll be doing this with our practice set. We'll be moving on to our solved example from page number 48. Now, before this section ends, I want to generalize a way in which roots of equation, that means alpha and beta, are used to form a quadratic equation. So this example is from page number 48. It is given that obtain the quadratic equation if the roots are minus 3 and minus 7. So that means alpha is equals to minus 3 and beta is equals to minus 7. So we have this information. Now, before we start off solving, we just need to make a comparison. So let's say I have a standard equation ax square plus bx plus c is equals to 0. Now I'll be just dividing the equation by a, and let's see what happens. Dividing equation by a. So this gives me x square plus b by ax plus c by a is equals to 0. Now we'll trace back a little bit and we'll see. Now all you have to do is pay attention here. We know that alpha plus beta is equals to minus b by a. But as we can see, I already have a b by a here. So that means I can substitute b by a as alpha plus beta. So alpha plus beta is equals to minus b by a. This implies that b by a is equals to minus of alpha plus beta. That means I can substitute the value minus alpha plus beta in the place of b by a, which means that this value, let me use a different color, which means that this value can be substituted in the place of this particular b by a value. Now, moving on to c by a. We know that c by a, or rather alpha into beta, is equals to c by a. Now, as we can see in our equation here, we have c by a here. So I can simply substitute c by a. I can simply substitute c by a is equals to alpha into beta. So coming to our final solution, I have x square plus b by ax plus c by a is equals to 0. Now alpha plus beta is equals to minus b by a, and alpha beta is equals to c by a. So just substituting the values from 1 and 2. This gives me x square. Now remember, here we have plus b by a, and here I have minus b by a. So when I write alpha plus beta, the sign is going to change. This is minus alpha plus beta plus alpha into beta is equals to 0. So if I know two equations, or rather two roots of a quadratic equation, the quadratic equation can be formed in this way: x square minus alpha plus beta plus alpha into beta. Now coming back to our example, we have alpha is equals to minus 3 and we have beta is equals to minus 7. So all I need to do is substitute the values. So I have x square minus alpha is minus 3 plus beta is minus 7. This is plus alpha times beta is minus 3 into minus 7, which is equals to 0. This implies x square minus 3 plus minus changes the minus sign. So I have rather plus minus does not change the minus sign. So this is minus 3 minus 7 plus minus 3 into minus 7 is positive 21. So this is plus 21 is equals to 0. But this is x over here. Do not miss this sign. We have an x here. Pardon me, I made a mistake because we have an x in our quadratic equation. So this is x square minus alpha plus beta x plus alpha into beta. So here I have x, and then once I get this, all I have to do is evaluate the complete equation. So here I have x square minus, and inside the bracket I have minus 10x plus 21 is equals to 0. This implies x square minus minus becomes plus. I have plus 10x plus 21 is equals to 0. So this is my quadratic equation for roots. For roots, alpha is equals to minus 3 and beta is equals to minus 7. I hope this section was helpful for you. In the next section, we'll be seeing more examples from outside of our textbook in order to understand how to solve questions which involve two different roots, alpha and beta, and how you can solve questions from your practice set to understand this concept much better. This section will end now. Thank you.